In July 2025, an object from outside our solar system crossed the orbit of Mars. We had less than a week's warning. It was a comet, designated 3I Atlas, moving at 58 kilometers per second, faster than anything that has ever come from our own sun. It was a comet. But ask any planetary scientist one question, and watch their expression change. What if next time it isn't? There are planets out there, untold numbers of them, that belong to no star. They were ejected from their birth systems billions of years ago, some by a gravitational collision with a giant neighbor, some during the chaos of a stellar flyby. They drift, dark and silent, through the void between galaxies, carrying nothing but cold rock and, in some cases, a deep frozen ocean sealed under miles of ice. Our previous video explored what these worlds are, how they form, and the strange possibility that life might persist beneath their ice. If you haven't seen it, it's worth watching. This video asks a different question, one that, after 3I Atlas, feels considerably more urgent. Could a rogue planet cross our solar system? Would we see it coming? And if one did arrive, what would actually happen? The answers are stranger and more reassuring than the headlines would have you believe. Before we talk about probability, you need to understand scale. In 2023, a team led by Takahiro Sumi and David Bennett published results from the MOA-2 gravitational microlensing survey in the Astronomical Journal. Their conclusion was staggering. The Milky Way may contain approximately 20 times more rogue planets than stars. 20 times more. Our galaxy has roughly 400 billion stars. Supposition, statistical estimate, not a direct census. Run that math and you arrive at a number in the trillions, perhaps more. And crucially, rocky Earth mass rogues appear to be more common than the gas giants. They are not rare oddities. They may be the most common type of planet in existence, and we have been almost completely blind to them because they don't orbit a star. They emit no visible light. They simply move through the dark, invisible. That invisibility matters because it sets up everything that follows, which brings us back to 3I Atlas. On June 30th, 2025, detected by the Atlas Survey Telescope in Chile, astronomers identified a comet coming from interstellar space. It passed within roughly 1.4 astronomical units of the Sun, inside Mars's orbit. At 58 kilometers per second, it was moving faster than Oumuamua, faster than Borisov, and we had almost no time to react before it was already here and gone. That is not a rogue planet, but it proves the point in real time. Interstellar objects do enter our solar system. The question is what kind and how often. Garrett Brown, a researcher at the University of Toronto who has modeled these scenarios, offered this estimate in an interview. Roughly 1 in a billion chance that a rogue planet enters our solar system in the next 1,000 years. And the odds of one reaching the orbit of Mars? Approximately 1 in a trillion. 1 in a trillion. That is not a threat we lose sleep over. But here is the thing about astronomers. They study it anyway, because the universe operates on timescales where even 1 in a trillion events happen, and because understanding the what if has already taught us something genuinely surprising about our own past. We will get to that. Let's say a rogue planet did enter our solar system. What would the effects look like? The first thing it would encounter, long before reaching the inner planets, is the Oort Cloud. This spherical shell of icy debris surrounds our solar system and extends up to roughly 2 light-years from the Sun. It contains somewhere between 100 billion and 1 trillion comets. It is essentially a gravitational minefield. A large object passing through the Oort Cloud would perturb those comets, knock some out of their stable orbits, send a fraction of them diving toward the inner solar system. The result, in models, looks like what scientists call a comet shower, an elevated rate of cometary impacts lasting, in some simulations, 2 to 3 million years. That sounds alarming, but the key phrase is passing through the Oort Cloud. For a rogue planet to actually destabilize Earth's orbit, to directly threaten the gravitational architecture that keeps us in the habitable zone, it would need to pass within roughly 5 astronomical units of the Sun. That is inside Jupiter's orbit, and it would need to carry something close to Jupiter's mass. Supposition, based on orbital mechanics modeling. The Oort Cloud is vast. The inner solar system is a comparatively tiny target, and even a comet shower, while potentially catastrophic on million-year timescales, is a very different threat than a planet bearing down on Earth. The honest summary: proximity and mass are everything. Oort perturbation is plausible. Inner solar system disruption requires an event so improbable it belongs in the same category as nearby stellar explosions. Here is the part that actually keeps astronomers awake. Rogue planets are dark and cold. They emit no visible light. The most striking example discovered so far is WISE J08550714, a substellar object with a temperature of roughly 285 Kelvin, warmer than a kitchen freezer, but cold enough to be invisible to any optical telescope ever built. WISE J0855 sits just 7.4 light-years from Earth. It is the fourth closest known system to our Sun, and it was completely unknown to us until 2014, when NASA's Wide Field Infrared Survey Explorer finally captured it in infrared. Something that close, that cold, that dark, invisible for the entire history of human civilization. We only found it because we built a dedicated infrared space telescope. Microlensing, the technique used to detect most rogue planets statistically, only works when a rogue happens to pass in front of a background star from our line of sight. It tells you a planet existed in a given direction. It tells you almost nothing about where it is now or where it is going. This is about to change. NASA's Nancy Grace Roman Space Telescope, scheduled to launch in September 2026, is expected to detect approximately 400 Earth mass rogue planets during its primary survey. The Vera C. Rubin Observatory, which began its legacy survey of space and time on June 30th, 2026, will add wide-field optical depth that no previous survey has matched. In January 2025, a team led by Subo Dong published results in Science, confirming the first rogue planet with both mass and distance measured simultaneously. Roughly 70 Earth masses, located about 9,150 light-years away, detected in a 24-hour observation window using the KMT-net, OGLE, and Gaia networks working together. We are getting better at finding what was never supposed to be found. We don't have to speculate about close interstellar encounters. They have already happened. About 70,000 years ago, a small red dwarf star called Schultz's star, cataloged as WISE J07-0846, passed through the outer Oort Cloud at a distance of approximately 0.82 light-years, or roughly 52,000 astronomical units from the Sun. This was confirmed in 2015 by Eric Mamajek and colleagues, published in the Astrophysical Journal Letters, based on 10,000 gravitational simulations, where 98% of runs placed the star through the outer Oort region. Homo sapiens was already walking the Earth. No one knew. Looking forward, a star called GJ710, a dim K-type dwarf, is predicted by Gaia data to pass within roughly 0.2 light-years of the Sun in approximately 1.35 million years. That is closer than Schultz's star. Its Oort perturbation will be more significant. We know it is coming with more than 1 million years to prepare. For comparison, stellar encounters within 1 parsec of the Sun, a considerably larger radius, occur roughly 19.7 times per million years, according to Gaia data analyzed by Baylor-Jones, 2018. The cosmos is far more dynamic than it appears from a single human lifetime, and now the idea that reframes everything. A 2025 preprint, Raymond et al., with approximately 3,000 computer simulations, proposed something remarkable. Speculation, preprint not yet peer-reviewed at time of writing. They suggest that a flyby of an object between 3 and 30 Jupiter masses, passing within roughly 20 astronomical units of the young Sun, may have been the trigger that launched the Nice model instability, the gravitational reshuffling that placed Jupiter, Saturn, Uranus, and Neptune in their current orbits. Their current orbits are the reason Earth sits in the habitable zone today. If this hypothesis holds, then the danger we fear from a rogue flyby may be the very same mechanism that made our existence possible. A dark, wandering world passed through our solar system 4 billion years ago, and instead of destroying us, it set the table for life. A rogue planet is not coming for us, Not in any time frame a human mind can meaningfully hold. But that is almost beside the point. The real discovery is this: the Milky Way is full of dark worlds we have never seen, trillions of planets drifting in silence, orbiting nothing, witnessed by no one. And until very recently, we lacked even the tools to prove they existed. In September 2026, a space telescope will begin cataloging them, and the Vera Rubin Observatory is mapping the sky right now. 3I Atlas crossed Mars's orbit and reminded us that interstellar space is not empty. It is crowded, just on timescales that dwarf our civilization. The question was never really whether one of these worlds might reach us. The question was whether we would finally be able to see them coming. We are just now learning how. If you want to stay ahead of what we find out there, subscribe. Every new signal will be